And we're back.
We're back. Industrial programming. Okay, this course is kind of everything that's laid out in the title. We're going to focus on PLC programming primarily this quarter. We will.
But it's not just about.
It's not just about programming PLCs. It's really about. Like, we have programming methodology, and we're going to talk a lot about like concepts in control. We're going to talk a lot about concepts in like generalized programming concepts.
Yeah.
Is really what it comes down to.
The thing is that like there are a whole bunch of programming languages.
Yeah.
Right.
There are hundreds of them.
Hundreds of them, and you know, like there's more that are no longer used than are used currently. But you'll occasionally run into some of these ones that are ancient.
Yeah.
Like
Pascal.
Like Pascal.
Or Cobalt.
Things that are so old that I learned to program in them way back in the day. You know, like, because I'm ancient now.
Yeah.
But, the programming, though, hasn't changed all that much, and the thought processes and workflows that go into constructing good code
have not fundamentally changed.
And once you learn how to program in one thing, it's just about like just syntax changes.
Syntax and being able to map one of these general concepts into the language that's being used, and recognizing where like a programmatic structure is existing.
Yeah.
And we'll talk about that in detail in this class. So like
it's going to span a whole lot, right?
Yeah.
You're going to be learning how to program in any language through learning how to program in a specific language.
And this particular class, the language that we are going to implement more often than not is going to be ladder logic. We may dip into a little bit of the other programming languages for PLCs, and we will talk explicitly about them. We are going to mention them because there are 5.
Yeah.
4. One of them got depreciated.
One of them got depreciated.
Yeah. There are 4 major ones that are going to kind of be universal to PLCs. We're going to talk about those. You're going to know what they are. We're going to primarily focus on learning ladder logic and using that programming paradigm to take control of the system you're building this quarter. At a broad level, really the concepts that we're laying down in this class are going to be carried forward into all of the other classes moving forward, because there's going to be aspects of control and programming for
everything.
It's
what makes mechatronics.
Yeah.
Not electromechanical.
Not electromechanical, not an electrician, not a mechanic. Like a mechatronics technician is somebody that does all 3 of these things, and the programming side of this and the control side of this is fundamental to what makes mechatronics.
Yeah.
With that in mind, this class is going to have, since you're not going to have a physical system right away to program on, we're going to...
Because you're building it in the other 2 classes.
Yeah, you're building it in the other 2 classes. The methodologies that we employ here, we're going to be working with some particular software this quarter that's going to provide us the ability to simulate systems that exist in real life and to work with these things in a digital environment at the beginning. As we move through this quarter, there will be a transition point somewhere. It's hard for me to be able to predict exactly where that's going to be right now. But at some point this quarter, you will transition over to programming your physical system. And when that happens, you should have all of the knowledge necessary to implement the functionality that's going to be required for that system at the end of the quarter.
Which is an interesting thing that's going to happen with the videos on this side. We're going to have broad discussion-based topics.
Yes.
But we're not going to know exactly, when we're shooting these videos, when it works for your class to transition over to the programming being what you're physically doing in person.
Right.
So we're going to try to avoid talking about...
Like, this is what you do with this sensor on your PLC, on your system. Like, we're not going to look at it from that perspective when we're talking about things. It's really
'Cause
generalized
it's
topics.
going to depend. Every quarter is going to be different.
Yeah.
You're going to be working through the lab exercises, and you've got to build before we get to the programming of the PLC physically on the machine. You've got to have the PLC wired, and in order to have the PLC wired, you need to have the mechanical apparatus on that machine already hooked up. And so, things are going to happen in the order that they're going to happen, and not every class is going to get to the same point
At the same time.
every single quarter.
Yeah.
So, like these videos that we're going to have here, we're going to be purposefully general
Yeah.
about, and we're going to try to avoid talking about what you're working on in
a
particular class
like
at a particular time.
yeah, and here what will happen in the lab portions of this class when we're meeting in person is that the translation from the topics that are discussed in lecture will then be applied contextually based on where you guys are at with the systems build. And so if you're farther along in one quarter of this, we will contextualize that for you in the lab, which is, again, another reason why it is super important that you show up for labs. You will not be able to complete this course if you do not show up for labs.
Pardon me.
Yeah.
No, it's super important that you're here, because even though some of your work you might not be able to do at home, because you don't have the licenses for it.
Yeah.
It's going to be important that you spend your time here doing the work.
Yeah. So there's going to be the software that we're using this quarter, and actually generally talking about the software, I think at a high level here. PLC programming software is a license-based software. The licenses are rather expensive. It is not going to be a normal thing. Do not expect to be able to go and download the programming environment for any PLC for free, like you might be able to do with other types of programming languages.
I mean, on some low-end components that may be true.
Yeah, but broadly speaking,
there is licensing fees for the program, like the stuff that you use that's on top of the amount that you pay for the hardware. And it's important to get used to. You're not going to be able to have this installed on 5 different computers.
Yeah, there will be essentially 1, maybe 2 computers that have the appropriate licensing for you to be able to do this work with.
Yeah. So it's important then that you are efficient when you're doing that work. And
Yes.
so part of that is, these videos, we're going to have a couple of discussion videos where we talk about broad concepts of how you program in every single language. But you're also doing...
There's going to be tutorial videos that are going to be explicit kind of walkthroughs about how you interact with something in the software that we're using. TIA Portal, Factory IO, Allen Bradley, whatever the software is for this quarter, there's going to be accompanying tutorial videos that show you explicitly how to navigate the software, how to do the basic fundamental things as reminders. But the intention there for those is that those are things that you refer back to as you're completing the project-based assignments that you have throughout the quarter.
Yeah, and so that work that you've got to do, you're going to have to do a lot of that here in the computer lab.
Yeah.
That's why we have the blocked out amount of time for you to be here, and you need to be working during that time. So to make the most of that time, it's going to be crucial that you watch the videos, but in addition to that, plan out how you're going to tackle it when you get in class. If you come up with a plan,
You will be much more efficient.
you will be much more efficient and much less loss, and you will get through the work in a pleasurable manner when you're here on campus and not feel stressed about getting it done by the time
The
class is over
with,
and-
or whatever, or having to stay late, or stuff like that.
Yeah.
So when it comes to the programming side of this, the majority of the program we do is actually going to be physically here on campus, for the most part. There might be some quarters, there might be exceptions. Hard to predict that. But the intention is that you are here on campus, and then when you're in class with your instructor, myself, Jason, Carlos, whoever it is, they will be a resource for you to ask questions and help you troubleshoot, but the onus is on you to complete those assignments. We're not going to have a group session when we're in lab where we'll throw up the software and show everybody and have a 30-minute tutorial on how to do something.
Yeah.
It will be, the expectation will be, here's today's
It's
assignment.
instruction on demand.
Yeah, kind of, yeah. And then, so on the lectures regarding the programming stuff, make sure that you're taking notes on the lectures. Come prepared to ask questions about that. That's going to be super important for success in this class.
And coming with a game plan for how you're going to tackle what you're going to do in class.
Yes, exactly. And we're going to work through the workflow about how you tackle this kind of systematically throughout the quarter. You're going to get reps on doing the workflow that we kind of want you to follow.
But oftentimes you're not going to have the introduction to what you're working on in the video itself. You're going to have to look at what the assignment is and come up with a game plan for how you're going to attack that based upon what we did say in the video.
Exactly. And then be prepared to ask questions about the assignments when you guys show up to class, because that's where those questions will be answered. I think that wraps it up for us. Is there anything else you want to?
I mean, about programming?
Yeah. I think we're.
I mean, this is their first. This is going to be really their first go at a lot of programming.
Yeah.
You know, this could be intimidating for some people. It could be old hat for other people. But you know, the important thing to understand is that programming is the art of talking to an idiot.
Yeah, I mean that's very true.
So, like,
computers are dumb.
The computers are dumb.
They are going to do exactly what you tell them to do every time.
No more.
Without fail. They will not anticipate. They're not going to interpret. They have no understanding of context. You have to be explicit with what you want them to do.
And so, you know, like, you may come with this preconceived notion that, like, it takes a lot of smarts to do this. No, it takes a lot of dumbs. Like, you actually have to...
Yeah.
Like, you have to put your mind down in, you know, the most literal, stupid place.
In many ways, like, it becomes kind of talking to a child in some ways. Like, a very young child where you have to be very explicit about every step along the process. There's no opportunity for them to infer meaning from the words that you're speaking.
Yeah.
It's the exact same with computers and logic controllers of any type.
Yeah. So it's you know, you have to think logically.
Yep.
But it's not as hard as it seems, and the reason why most people struggle in these classes, in programming classes in general, or what is they're running into a brick wall because they think that they're not they're not smart enough to get it, and they're making it more complex than it needs to be.
Yes. I think that's a very good point.
Like the answer to what this problem is that you've been struggling over and bashing your head against the desk and just thinking you can't possibly wrap your brain around how this works, is that you are thinking that it's more complex than it is. It's actually quite simple.
Yep.
And if you constantly look for the easier route, you'll be fine. You'll be fine.
A couple pitfalls that common pitfalls is that people will overcomplicate a programming problem. Mm-hmm. What we're looking for at the end of the day is the functionality, and then there's going to be nuance in terms of how you get there. Like in some cases, doing things a particular way will be more correct than others, but it's not going to be. Like,
there are shades of gray there.
There's shades of gray there. There's
it is like turning in a writing assignment, like, you know, for English, you know, or what have you. Like, you're going to have your own style and way that you like to organize things. You are going to, I mean, there is sort of a right way. There's sort of a wrong way.
Yeah.
But there's a whole lot in between that's acceptable. In essence, the right way is the code that works in the shortest space as possible.
Yes. And the when it comes to the programming side, we will talk about the nuances, and we will show you examples of when one solution is more correct than another solution,
Yeah.
and we'll explain why. But in this process, we're going to spend a lot of time essentially learning how to think in a fundamentally different way than I think what we do in everyday conversation for the vast majority of
Because
them.
we don't have to.
Yeah.
I can tell you, can you go pick me up a burrito? And you'll just go do it.
We're not like you don't need to be told, extend your arm, open the car door, like grasp the handle of the door, pull back, open the door until approximately 45 degrees, let go, put your hand back down.
And even then, he was skipping a number of steps there.
I was still skipping a lot of steps that you would have to tell a computer explicitly to do, right?
Yeah.
We can, and so having to do that, like thinking in that way, in that level of detail, is really, I think, the big barrier to programming in many ways.
Yeah. And the other good thing about it, too, is that, like there are drift-on characteristics. If you get good at programming, you tend to become better at safety.
Yes.
Because you're constantly thinking about the exclusionary things that you take under assumptions.
Right.
Most things you just think you don't think about the hazards that like it would take an idiot to do, but that's how warning tags get on things, right?
Yeah.
And that's really what it comes down to, is that learning programming is going to get you better at safety.
And learning programming is also going to get, actually, interestingly enough, not only like safety in terms of like working with machines, but also just kind of like safety and recognizing when things can go bad.
Right.
Because once you understand programming, you inherently kind of understand how machines interpret the world around them.
Right.
And you will recognize situations that can be unsafe because you know how the machine is going to interpret a signal.
Yeah.
Right. But we'll get into all of that.
We'll get into all of that. That's the purpose of this course.
Yeah.
Yeah.
So, with that being said, this one ran a little bit longer, but I think it was good.
Info.
Good info.
All right. Cool. We'll
you.
see y'all next video.
Until the next video.